Let us look at another example of modified internal rate of return, or MIRR in short. A project has the following cash flows. So we have been given years 0 through 5 and their respective cash flows in rupees. Now the project requires two cash outflows at years 0 and 2 and produces positive cash inflows in the remaining periods. So basically there are two cash outflows. One is this and the other is this. The project's cost of capital is 10% and its MIRR is 13.5%. What is the value of the project's cash outflow in the second year? So we have to find out what is this value of cash outflow. We have been given the cost of capital and the modified internal rate of return. So this is the cash flow representation on the time scale. Now we know that MIRR is that discount rate at which the present value of the cash outflow becomes equal to the present value of the terminal value of cash inflows. So let's first find out the present value of the cash outflows. Now we have been given that the cash outflows are at year 0 and year 2. So basically we have to find the present value of this cash flow. Now the present value of the cash outflow will be calculated at K, which is given to us as 10%. K is the cost of capital. The cash outflow of 250 rupees is already in its present value terms. So we'll keep it as it is. So let's say this is PV0. And let's say the present value of X is PV1. So basically the present value of the cash outflows is equal to PV0 plus PV1. Now PV0 is 250. I'm taking the absolute value. I'm not taking the negative sign because negative sign is just an indicator which tells us that this is a cash outflow. Plus PV1. Now we know that future value is equal to present value into 1 plus K to the power N, or PV is equal to FV divided by 1 plus K to the power N. Generally this K is actually I in the formula. However, since here we'll be using the cost of capital, which is represented by K, so I've used K here. So future value is X divided by 1 plus K, which is 10%, so that means 0.1. 10 divided by 100 is 0.1 to the power N. Now number of years for which this is being discounted is 1, 2. So this is equal to 250 plus X divided by 1.1 square. Now next, let's try to find the terminal value of the cash inflows. So basically what we have to do is we have to find out the future value of all the cash inflows and let's say this is 300. So this will be FV1, FV2, FV3 and FV4. And when we add all of them up, we get the terminal value of the cash inflows. Now this future value of these cash inflows will also be compounded at the cost of capital, which is 10%. So K equals to 10%. So TV is equal to FV1 plus FV2 plus FV3 plus FV4. Now we know that future value is equal to present value into 1 plus k to the power n. Now, typically in the generic formula, k is actually I, but here since we are using cost of capital as the compound rate, so we are using k in the formula. So this is equal to PV1 into 1 plus k to the power n1 plus PV2 into 1 plus k to the power n2 plus PV3 into 1 plus k to the power n3 plus PV4 into 1 plus k to the power n4. Now PV1 is 100. So 100 into 1 plus 0.1. N1 is 1, 2, 3, 4. Because we are going to compound this 100 rupees to 4 years. Plus PV2 is 150 into 1 plus 0.1 to the power n2. Now this 150 rupees are going to be compounded for 1 and 2 years. Plus PV3 is 275. So 275 into 1 plus 0.1. Now this is going to be compounded for 1 year. So to the power 1. Plus PV4 is 300 into 1 plus 0.1. Now N4 is 0 because 300 is at the end of the tenure, so it cannot be compounded for any duration. So basically we found out the terminal value, which is 930.41 rupees. We have also found out the present value of the cash outflows, which is 250 plus x divided by 1.1 square. So now we have to find out the rate at which the present value of this terminal value of cash inflows will be equal to the present value of the cash outflows. Let's say this is PVT, and this rate at which these two will be equal will be the MIRR. And we have been given that MIRR for this project is equal to 13.5%. So basically the present value of cash outflow is this. So 250 plus x divided by 1.1 square is equal to, now present value is future value divided by 1 plus I to the power n. Now in this case, this I will be replaced by R, which is nothing but the MIRR. So basically the present value becomes future value divided by 1 plus R to the power n. Future value is 930.41, which is the terminal value, divided by 1 plus, now we know the value of MIRR, which is 13.5%. So 13.5 divided by 100. So this will be 0.135. And this to the power n. So this is being discounted. The terminal value is being discounted for 1, 2, 3, 4, 5 years. So we have to solve this equation for x. So or, now x divided by 1.1 square is equal to, we'll take this 250 on the other side, so this will become minus 250. 930.41 divided by, now 1 plus 0.135 to the power 5 becomes 1.88355 minus 250. So or x divided by 1.1 square is equal to, now this comes out to be 493.966 minus 250. or x is equal to, so this becomes 243.966 multiplied by 1.1 square. So x is equal to 295.19 rupees. So the cash outflow for the second year is 295.19 rupees.